All right, welcome to the quick in-class review that you're missing today before the quiz that you're also going to get shortly. So this is going to kind of just review some of the key ideas that we've been talking about. And the two things we've been talking about are transformations, like how are you moving or shifting your graphs with function notation, and then just being able to identify from a shape of a graph which family of power functions that graph will live in. And then down the road, we're going to put those two things together. So we're going to be taking our graphs and then we're going to actually physically transform them. So you've done this a bit with Desmos activities. So on the quiz, you're going to see things like this, where I'm going to give you function notation, and I might put something in here like an 8. But I might put it on the outside instead. And so we need to know the difference between what is this doing to my function, how's it moving it, and what is this doing to my function and how's it moving it. And in contrast to that would be something along the lines of if I had f of x minus 8 versus f of x in parentheses, and then the minus 8 is on the outside. So your job when you're looking at these and deciding is twofold. One, is the number inside the parentheses or is the number outside of the parentheses? So the number inside the parentheses is going to go right or left every time. So I automatically know this is inside the parentheses. It's going to go right or left every time. This is outside the parentheses. So is this one. These two are going to go up or down. It's a vertical shift, up or down. So this would take whatever my graph was. So if my graph, I'm going to put it in blue to begin. If my graph were just a parabola, and this plus 8 is outside, so this blue thing is f of x, and I'm going, well, let's add 8 to my graph. So I'm just going to take that graph, and I'm going to literally count up 8 places. 1, 2, 3, 4, 5, 6, 7, 8. That graph just literally moved up 8 places. That's your plus 8 on the outside. So the minus 8 on the outside would take this original graph, and it would just go 1, 2, 3, 4, 5, 6, 7, 8. There it is. That's the function moved down 8. So the plus or minus on the outside is just literally taking that blue graph and moving it up or down. So a plus, if you think about it, positive is going up and a negative is going down. So the numbers on the outside of the parentheses are literally just doing exactly what it looks like in terms of movement. A plus is up and a minus is down. Now, things get weird on the inside of parentheses. So anything that happens inside the parentheses, we are going to call the land of opposites, which means the opposite of whatever the sign is actually what's going to happen. So this 8 has a plus, but I'm talking about land of opposites, so that's going to move my function left 8 spaces. So it would take this blue graph and it would go 8 to the left, even though that's a plus, because everything in here is the land of opposites. So if I go 1, 2, 3, 4, 5, 6, 7, 8, that has the plus 8 in the parentheses. Kind of tricky. Which means if it's a minus 8 in the parentheses, again, it's right or left because it's in parentheses, but it's opposite, land of opposites in here. So a minus is going to move me to the right 8 places. So I'd go 1, 2, 3, 4, 5, 6, 7, 8. That's where my graph would live. And now I have a minus 8 in the parentheses. And the reason that's opposite in the parentheses is if you were going to solve this equation right here, to solve for x, you would have to do the opposite of what's in there. You would add 8 to get x by itself. So adding 8 is moving to the right 8. Out here, to get x by itself, I would subtract 8, which is a move to the left. Notice on this one, x is already by itself. I don't have to move anything or do anything to it. That's why this is just straightforward. There's no mix-up. So I'm going to give you a couple, and your job is just going to, and let's see, my favorite number is, we'll just use 100. So if I have f of x plus 100, f of x minus 100, f of x plus 100, goodness, that's some bad handwriting, f of x minus 100, apologize for this thing. Your job is just to take a second and tell me what the, and this is what the quiz is going to do. What is the transformation? What's happening? And that's just telling me right or left, up or down, and then how many units. And so it's really a direction and a unit. So take a few seconds and try to answer these. I'm going to I mean, I'm just going to sit here. I'm not even going to tell you to pause the video because you can be doing it right now. And then I'm just going to write the answer. So take a second or two to try to answer these. Okay, your answers should be, and I'll pause in case you're not done yet. This one would move my function up 100 units or spaces. This one would move my function down 100 spaces. This one, inside land of opposites, this would move my graph left 100 spaces. And again, this is inside, so it's land of opposites, so this would move it right 100 spaces. All right. There you go. Hope that helps. There is also a small trick, and that is, what if I put a negative sign in front of f of x? So if I go back to my original graph, and I go to my parabola, so if f of x, which is the same as y, these are my y's, are all above the x-axis, if this negative is outside of my function, it's going to turn all of my y's negative. So that transformation is actually going to put it underneath. And what's it called when you have an image and then you kind of look at the same image but it's flipped over something? That's kind of a little tricky one I put into the quiz for you, so hopefully that doesn't stump you. All right, moving on. Next topic. Next topic is talking about the power function graphs and being able to recognize which ones match which. So in general, we have 6 of them. So I'm going to draw all 6. 1, 2, 3, 4, 5, 6. I don't think I have 6 colors, but so we'll start with this. So anything that just generally has a U shape, goodness, anything that has a general U shape, some kind of U, is the function is f of x equals x, and the power is just an even number. So for example, this could be x squared, x4, x to the 100, all even numbers. They look similar to this in terms of they make a U shape. Some of these bigger powers will make more of a square U shape than a rounded U shape, but they'll all be making a U shape. So I'm going to switch this to an odd exponent. There's a lot of weird things. This side of the odd exponent is exactly the same as the even side. This comes down like this, but because when I square things or take things to the an even power, if I square a negative number, the answer becomes positive. So that's why this one curves back up. But if I take an odd power to a negative number, it stays negative. So this thing twists down here. So it's basically the right side is the same as the even, but the left side is just twisting this part on the bottom. So that's x to any odd. It's long and stretched out, top to bottom. So that would be like x cubed, x to the 9th, etc. Any odd power up there. And x to the 1st is a special case, and I'm going to put that over here because I'm going to do a separate one for that. It follows this pattern, but this doesn't have any curvature to it, so I'll probably do it on this graph in a second. Now I'm going to switch to, I guess, negatives. So f of x, no, actually I'm going to switch to fraction up here, so like 1 over an even. And again, if it's a fraction up here, it's one of 2 graphs. 1 over an even would be like x to the 1/2, which is the same as a square root of x. Or x to the 1/4, which is the same as the 4th root of x. There are 2 different ways to write the same thing, but they all are going to look kind of the same. They're going to start right here, and they're just going to kind of make a little whoop. Nothing exciting going on. There's nothing over here. And the reason is If you try to take a square root of a negative number, like -9, if you put square root of -9, the calculator is going to tell you error. So can't take a square root of a negative number, so it's just kind of like a half graph. It's the only one that's just like a half a graph, and it's 1 over an even. So if I continue, and I'm just going to go down this way now, and go f of x equals x to the 1 over an odd, that would be like x to the 1/5, or the 5th root of x. Those are the same thing, two different ways to express the same expression. And an odd one, again, just like the pattern up here on the right side of these two graphs was the same, the right side of this graph looks just like a 1 over an even, identical. But I can take an odd root of a negative number, so it twists down here and looks like that. So again, the top part is identical, but it has a little twister on the bottom. So if you notice, when I was having you look at things that kind of look similar, x to an odd and x to a 1 over odd are kind of the same. An odd has a big number up here, so it shoots up really fast. This has a fraction up here, so it just gradually climbs up. All right, I'm going to see if this is going to be a little fancier, but I'm going to do it anyway. So I'm going to go... Oh, no, I don't like that at all. I changed my mind. Going back to red. All right, f of x equals x to a negative even. Now this is the same as like x to the -2 or 1 over x squared. So I have an x in the bottom. That means I can't ever cross 0 because I can't divide by 0. This one looks like a volcano. But notice it's a mirror image of itself on the top, just like x to a positive even. And then if I do f of x equals x to a negative odd, that would be like a 1 over x, which is the same as saying x to the -1. And again, it puts x in the bottom, so I can't ever cross this. And just like all of the other graphs, this side, the right side, looks exactly the same, boop, as my x to the negative even. But again, these are positive because when you take an even power of a negative, it makes it positive. This one is just down here. So these two kind of have some similarities in comparison and contrast to each other as the even and odd, as the negative even and negative odd. So real quick, I'm going to come back over here. X to the first is just a line, and so it would look like this. So notice how it has the same general pattern, it just doesn't have any curvature. All right, so I'm going to put some graphs on here, and I want you to kind of pick and choose. So give me a second to put some graphs on here, and then you're going to pick and choose. All right, your job is to look at these 6 graphs, and then I only put 5 equations down here, so I'm sort of messing with you. And you want to match which of these functions could be graphed up here. And I want you to pause the video and actually try to match these up, like put a letter by this graph. So like put a letter, if this were A, put a letter A here. So pause the video, please do that. And then when we unpause it, when you unpause it, then I will take a second and put the answers up. So pause the video and try this. Do it. All right. Hopefully you actually paused it and completed your task. So I'm going to show you the answers. This is 1 over x to the 10th, which is the same as x to the -10. So that's a negative even. A negative even is the volcano right here. So this should have been A. X to the 1/6 is 1 over an even. And 1 over an even is the one that's just our half graph. Like 1 over half, it's like 1 over 2, square root type graph. So this would be the letter B. It's our half graph. This is a cube root of x, which is the same as x to the 1/3. Those are the same, so 1 over an odd. And 1 over an odd is kind of like 1 over an even, except it gets its left side tail over here as well. So this one is squished down because you're taking a fraction up here, and it's just kind of starts the same as the even, but it has its own little tail, so that would be C. X to the -5th is negative odd. These are our 2 negative ones because they're the ones that have a split down the middle. They're the only ones that are actually 2 separate graphs, the negative ones. And so the even lives both above and the odd doesn't live both above. One's below and one's above, so this would be letter D. And that leaves the letter E,